Hello everyone and welcome to this video. So in this video we are going to discuss solution of the weekly contest 116. So we'll wait a couple of minutes for other people to join, and before that just let me know if I am properly audible, and put in the comments how many questions were you able to solve. Okay, I am properly audible, thank you. So someone is asking about question 2. Don't worry, we will be discussing all three questions. Okay, thank you. So we'll just wait for a minute and let more people join, and then we'll begin. Okay. Okay, 2-0. Okay. Okay, Nikhil was able to solve all three. Great. Okay, Nipun is asking, was today's contest tough? I think see, the question one was quite direct. Okay, if you are able to select a proper data structure or proper looping method, you can solve it in n square time. And if I tell you about other questions like the building question, then a little bit of top, you need to use a stack as well as DP. And the other question, subarray one, subarray question was looking tough, but if you can get the logic, then it was quite simple. Okay. Okay, 1-1. So don't worry, Nipun, this kind of ups and downs keep coming. In fact, like when you will solve the other two questions or you will understand it in this live session, you'll learn a lot more, right? Okay, so let's start with the question one, and by the time we finish it, more people will join, and then we'll discuss question two and three, right? Okay, so someone is saying brute force was throwing error to them in question one. Let's see my implementation. Then if you get, probably you will get what was wrong you were going. Someone is asking stack plus DP. Yes, if we look at the geeks building question, like if you stack was a standard thing to find the next greater height building, and then a little bit of DP, right? Okay, Aman. So let's start discussing. So I'll share my screen. So we'll start with the array game. Okay, so I hope the screen is properly visible. I So let's start with the first question. What does question one say? It says that you are playing an array game in which you are given two arrays, ARR and BRR, each of size n, right? Each array is a permutation of n positive integers. So each array is of size n, and both of them contains all the integers from 1 to n in some permutation. Okay. In one operation, you can perform either of the following two steps. First, rotate the array ARR, that is the first array, anti-clockwise, or the second operation which you can perform is remove the first element of both the arrays if they are the same, and find the minimum number of operations required to make both the arrays empty, right? So the example given is 1 2 3 and 2 1 3. So if I write here, so basically this is the example 1 2 3 and 2 1 3. Okay. So this is 213. So basically what they have said is we have two arrays ARR and BRR. Both of them are of length n. These are the n elements of ARR and these are the n elements of BRR. Now we are given two types of operation. In the first type, what we can do is we can rotate the first array anti-clockwise. So we send the first element to the last position and the remaining elements we shift them by one position to the left. That is, so we rotate the first array anti-clockwise ARR. And the second type of operation which is given is if the first element of both the arrays match, then remove them. So we will keep doing this procedure until both of the arrays become empty. Then how many minimum number of operations are required? So basically here what we need to do, simply we can keep rotating this array anti-clockwise until all the elements are deleted. So first of all it is 1 2 3 and 2 1 3. So the first element in array 2 is 2 and array 1 is 1, so they do not match, so we can't delete them. So I need to rotate the first array anti-clockwise, so it will become 2 3 1. So from here I'll come here and this will become 2 1 3. Now since both these elements match, what I'll do is I'll remove them because I need the minimum number of operations. So as soon as I get a match, I'll delete them. Okay, so I'll delete them and the remaining array would be 3 1 and 1 3. Again the first elements do not match, so I'll rotate the first array anti-clockwise and it will become 1 3. Second will also become 1 3. Again the first two elements match, so what I'll do is I'll remove them in our operation. Now 3 and 3. Now again both of them match, so I'll remove them and our arrays will become empty. So 1 2 3 4 and 5 number of operations were required, right? So if we look at here, the output is 5. Okay, also here the value of n is up till 500, so you can use two for loops, right? And at max it will go in n square time, because see, suppose my first array is 5 4 3 2 1 and the second array is 1 2 3 4 5. Then in order to remove the first element, I'll have to rotate the first array anti-clockwise how many times? 4 times. After doing 4 operations of anti-clockwise rotation, it will become 1, then followed by that would be 5, then 4, then 3, then 2, and here it would be how much? 1 2 3 4 5. Now the first elements match, I remove them. Again here is the 2 and here is the 2, so I need 3 operations, 3 anti-clockwise rotations. So the maximum number of operations can go up till big O of n square, and that is totally okay because the value of n can is up till 500, so we can afford n square time limit. So now how can we implement it? See, whenever I remove one element, I put it in at the end, and all the remaining elements are pushed to the left by one position. So can we use queue? So what I'll do is I'll first push all the elements in the queue. So suppose this is my array, then my queue would be 5 4 3 2 and 1. Now what I'll do, I'll match this element with the first element. If it do not match, I'll pop it out and push it at the end of the queue. So it will be kind of first in first out procedure. Then I'll push back 4, then I'll push back 3, and so our queue will keep rotating anti-clockwise. Okay, so now let's implement it, and then we'll take if any doubts are there. So initially answer variable will denote the number of operation. I have initialized it with 0. I am taking two variables I and x, and let's take one queue. So this queue would be of integers and queue. First of all, push all the elements of array ARR into queue. Okay. So for I equals to 0, I is less than n, I plus plus, q dot push ARR of I. Now until the queue is not empty. So while q dot empty equals to false. When will queue be empty? When all the elements are removed. So while all the elements are not removed, what I'll do is I'll take the first element of the queue. If x is equals to also, now I want the first element to be removed. So initially I want the index 0th element to be removed. So I am taking variable I to denote which element is supposed to be removed from array BRR. So initially I need to remove first element. Whenever there will be match, I'll increment the I to the next index. So if x is equals to BRR of I, simply increment I. So now we will consider next value in the second array to be removed. And else what I need to do, I need to push x to the back of the queue. So I'll say a q dot push x, and each and every time one operation will be considered. So I'll say answer plus plus. Okay. Also here I need to pop out the q after removing the element, right? And here I'll return the answer. So this should give me, let's compile. So this, now let's submit it. So we have solved this problem successfully. So if you people have any doubt in the implementation or concept, please let me know. Otherwise, we'll move on to the second question. Aman, did you got your, where were you missing? Any doubt, please let me know. Otherwise, we'll move on to the next question. Okay, okay. Yes, Aman, please go on. Yes, Tanu is asking, is anti-clockwise rotation similar to left rotation? Yes. If clockwise was given, we need to rotate it right. Okay, someone is asking, can't we manipulate original array? Okay, but if the value of n is up till 500, then we can afford n square, right? So why we should think of something complicated? Time complexity would be big O of n square. Someone is asking why I said that we can afford n square in case of 500. Okay, so basically, if the value of n is 500, if the value of n is 500, then n square would be how much? 25 into 10 to power 4. This much number of operations we can do it. Okay, probably the time limit would be 1 second. And when the value of n is till 1000, we can afford n square. Here it was even less than 1000, so we can do it with n square. Is there a more optimal solution? I am not able to think of it any right now, because see, if we were able to rotate both the arrays in any of the directions, then we might think of something. Okay, but here what is the case, that only the first array can be rotated, and that too in the anti-clockwise direction. So then we might, select at which index which element is present, and then think of something like complex, in which pre-processing is more, but the overall time limits get reduced. That we can think of. But since value is n value is 500, so we approached with the simple brute force approach. Can't we manipulate the original array? But how do you want to manipulate, like? Okay, so someone is asking to dry run the code on a test case. So let's do it. So basically, see, suppose my array is 4, 3, 1, 2. This is the first array ARR. And suppose I have BRR as, let's say, 3, 2, 4, 1. Okay. Now, what I'll do is I'll push all the first array elements into a queue. So it will become 4, 3, 1, 2. Right. Now, does the first element match with 3? No. here I have marked I index as 0 initially because I want to match this element. Once this element is matched, I'll take I to the next step, right? So does first element of queue match with this? No. So what I'll do is I'll put 4 at the back of the queue. So I'll get 3, 1, 2, and 4. Now does 3 and 3 match? Yes. So now I'll remove the first element. So my queue will become 1, 2, and 4, and my I will become I plus 1. So now I will become 1. It will point at 2. Now does 1 and 2 match? No. So I'll rotate it anti-clockwise. I'll push the 1 to the end of the queue. So 2 will become first element, 4 will become second, and 1 will be pushed back. Now does 2 and 2 match? Yes. So I'll remove them. So my queue will become 4 and 1, and I will become I plus 1, and it will now point to 4. Now does 4 and 4 match? Yes. So I'll remove 4. My queue will remain with one element, and I will become I plus 1. Now 1 and 1 match? Yes. So I'll remove them, and it will become empty. And here we can count the number of steps. Now is it clear? Okay. Tanuj Jain, is it clear? Okay, thank you. Okay, so we'll move on to the next question. Okay, so someone is asking to use ARR as a circular array and looping through B. But if you circulate the whole array, so for each operation, what you need to do is you need to go of big O of n, right? So suppose if my array is 5 4 3 2 1, and if the second array is 1 2 3 4 5, then the number of rotations in itself would be n into n plus 1 by 2, as we saw before. Now in each rotation, if you solve this using an array, then what you need to do, you need to shift all the elements to the front side and the first element to the last position, right? So that would again take big O of n time. So it will go into big O of n cube. Or what you can do is you can increment the value of I every time. So you can say I equals to I plus 1 modulo n. You can do it using this. So you can assume that array is rotating in anti-clockwise direction, but rather than rotating the array, you increment the index. And after the last index, you again come back to the first index. So this will not require big O of n time. This will be removed. So again, this would be done in big O of n square time. So then you can solve this. Can we do it by counting after which permutation we get BRR? See, you it might be possible that you do not get BRR after any number of rotations. Like the whole array may not match. If the first array is 3 1 2, and if the second array is, let's say, 3 2 1, so if even if you keep rotating it, they will not match exactly after any number of operations, right? Okay, just a minute. Okay, so someone is saying that it was not mentioned that uh, how many times can we rotate the array anti-clockwise in one step, right? But if it is said that rotate the array anti-clockwise, so it's basically rotate it by one position. That is the anti-clockwise rotation. But okay, like it can be improved a bit more. Like we can say rotate the array anti-clockwise only one step. Okay, right. But if nothing is mentioned, then by default you can assume one. Now let's move on to the second question. Subarray of length 2, and then geek and buildings. Okay, So subarray of length 2. Let's read out the question. Given an array A of n elements, in one operation you can select any subarray of length 2 and multiply all the elements of that subarray by -1. You can do any number of operations, possibly 0. Your task is to maximize the sum of all elements of all subarrays of A. Okay. So now here is the given example, -1, -2 and -3, and if we multiply the second and third element, that is we select the subarray with index 1 and 2 and multiply it by -1, the array becomes -1, 2, 3. Now the subarrays are as denoted -1, 2, 3, -1, 2, 2, 3 and -1, 2, 3, and the sum of all subarrays is 14, right? This is the maximum sum. So basically what they are asking is that whenever we are given an array, okay, suppose this contains n elements, it can be positive as well as negative. Now there is one operation which is defined to us. What is the operation saying? The operation is saying that select any subarray of length 2. What is a subarray? A continuous segment. So select any subarray of length 2 and multiply all the elements of that subarray with -1. So suppose an element is +5, it would become -5. Suppose an element is -7, it would become +7. Suppose an element is 0, it would remain 0. Right? So we can perform these operations on any subarray of length 2, and we can perform these operations as many times as we want. Finally, what we want is that we want to maximize the sum of all subarrays of that array, right? So suppose my array is 1, 2, then all the subarrays would be 1, 2 and 1, 2. There would be 3 subarrays. So the sum of this would be 1, sum of this would be 2, sum of this would be 3, and if I sum them up, it would be 6. So I want the sum of all the subarrays. So now we need to think of here, first of all, what we will do is we will try to, maximize the number of positive numbers, because we want the sum to be maximum. So if the number of positive numbers are maximum, then eventually the sum of all subarrays would be maximum, right? That is the first thing. Also, one thing which we need to consider is we should not directly judge an element seeing its value. So for example, there is an element, let's say 5 year, then we have, let's say 1 year, 1 year, 1 year, and then let's say 2 year, then let's say 3 year, and then let's say 4 year, or let's say here we have, let's say 3. Now this 5 value is greater than 3, but we also need to see we are calculating the sum of all subarrays, right? So it might be possible that 3 occurs in more number of subarrays than 5. So the overall contribution of 3 is more than 5. It might be possible. So before thinking about which element to make negative, which element to keep positive, we should also keep this in mind, right? So first of all, let us discuss. See here, the value of n goes to 10 to the power 5. So I cannot, generate all the subarrays and calculate the contribution of each element after generating all the subarrays. That would take a lot of time, right? So what should I do is, I should see each element contributes in how many subarrays. So for example, my array is 1, 2 and 3. Then my subarrays would be 1, 2, 3, 1, 2, 2, 3 and 1, 2, 3. Now instead of generating all these subarrays and calculating the sum, what I can do is 1 multiplied by the number of subarrays in which it occur, plus 2 into the number of subarrays in which it occurs, plus 3 into number of subarrays in which it occurs. So 1 occurs in how many subarrays? 1, 2 and 3. So the total contribution by 1 to the overall sum of all the subarrays would be 1 into 3, that is 3, plus 2 into number of subarrays in which 2 occurs. 2 occurs in 1, 2, 3 and 4. So here it would be 4. 3 occurs in how many subarrays? 1, 2 and 3. So 3. So my sum would be 3 plus 8 plus 9. That is nothing but how much? 20. So what should I do is I should calculate the contribution of each element and then multiply it with the value of that element and then sum all the elements. So I do not need to generate all the subarrays, right? Now how much one element would contribute? The element at the ith index will be a part of how many subarrays? It will be a part of I plus 1 into n minus I subarrays. How? Suppose I have an element, let's say 1, 2, 3, 4, 5, 6 and 7. I want to calculate how many subarrays does 3 occur in. So 3 occurs in 3, it occurs in 2, 3, it occurs in 1, 2, 3. So basically 3 occurs in 3 subarrays if 3 is the last element, right? So I can say the index of 3 I is how much? 2. So it is I plus 1 number of subarrays where the 3 is the last element. And if I look forward, then it can be 3, 3, 4, 3, 4, 5 and 3, 4, 5, 6. Let us remove 7 for now. So in how many subarrays does 3 occur when 3 is the first element? In 4. 4 is nothing but n minus I. N is 6. I is 2 for value 3. So this is 4. Now I can combine any of these subarrays with any of these subarrays. So suppose I can combine 2, 3 with this 3, 4, 5, 6. So my whole array would become 2, 3, 4, 5, 6. This is also one subarray in which 3 is there. Did you understand? So considering 3, there are I plus 1 number of possibilities on the front end side and n minus I possibilities on the back end side, and I can combine these conditions also. So suppose I can take 2, 3 and 3, 4. So my total subarray would be 2, 3, 4. This is also one possibility. So the total number of subarrays in which ith element will contribute will be I plus 1 into n minus I, if we consider zero index numbers. And how much its contribution will be? Its contribution would be I plus 1 into n minus I, that is the number of subarrays in which it occurs, into a of I, that is the value. So first of all, tell me, is there doubt in this much part? Okay, so someone is saying, is there a simpler approach? See, the value of n goes up till 10 ki power 5, right? So we need to find some way to calculate the contribution of each element in out of all the subarrays, that how much that element is contributing in an efficient manner. So I think we need to come up to this formula, I plus 1 into n minus I. Okay, so is this much clear? Now the second part of this question comes is, see, there would be negative elements as well as positive elements, and we want to maximize the number of positive elements. So what would be the best choice? The best choice would be when all the elements are positive, that would be the maximum contribution. Okay, now if you think a little bit, when it would be possible to make all the elements positive, there are two conditions, or we can say three conditions. Either all the elements are positive from the first, then we will not do any operations, or there is at least one zero in the array, or there are even number of negative elements. In these three conditions we can make the whole array positive, right? So how? See, if there are all the elements positive, we do not need to do any operation. If there is a zero, so what will happen is, see, let's say there is 1, minus 2, 3, 4, minus 6, minus 7, 0, 8 and 9. Suppose this is my array. So what I'll do is I'll start performing the operation from here. So my negative sign would keep going on the right hand side. So what will happen? First I'll perform the operation on these two. So I'll multiply them with minus 1. So it would become 2n minus 3. Now I'll perform the operation on this 2. So it will become 3n minus 4. Now I'll perform the operation on these two, so it will become 4 and 6. Now here I have -7, here I have 0. Now I'll perform the operation on these two, so this would become 7, this would become 0. So 0 will remain 0 only. So basically, if there is even 1 0 in the whole array, then what we can do is we can take all the negative numbers from this side and push the negative sign one by one position up till 0. Similarly, for all the elements on this side, we can push the negative sign one by one and dump it in 0. Like, not exactly pushing the negative sign, but here you can see the negative sign came from here to here, then from here to here, then this negative came here and it got dumped here, because for 0 there is no effect. So whenever there is at least 1 0 in the whole array, we can make all the elements positive. And when there are even number of negative numbers, so what does that mean? Suppose I have 1, -2, 3, -4, 5, 6, -7, -8. So first of all, I'll perform operation on these two, it would become 2 minus 3. Then I'll perform operation on these two, it would become 3 and 4, because both of them are minus. Now I'll perform operation on these two, it would become 7 and 8. So whenever there are even number of negative elements, we'll get two negative elements in pair after some operations and we'll make them positive. So all the array will become positive. And now the last case, when there is no 0 present in the array and there are odd number of negative elements. So suppose I have 1, 2, 3, -2, 4, -5, 6, -7. So here I can make either these, I mean there would be at least one negative element at the end, right? Suppose I perform operation on this two, this would be 2 minus 4. Suppose I perform operation on this two, it would be 4, 5, 6, -7. Now I don't want 7 to be minus, so I perform operation on this two, so this would be -6, 7. So in any case there would be at least one minus sign. Okay, is this much clear? Now what we need to understand is we want maximum sum. So if all the numbers are positive, well and good. If there is 1 0, well and good, at least 1 0. If there are even number of negative elements, well and good. If there are odd number of negative elements, then what we will do is we will make the element negative whose total contribution is the minimum in the whole subarray sum. Okay, because not the element whose value is the least. Okay, we will make that element negative whose total contribution is least. And what would be the total contribution of a particular element? It would be I plus 1 into n minus I into a of I. So for whichever element this value, the magnitude of this value is minimum, we will make it negative, and for all the other elements we will make it positive. Also remember, whenever we have odd number of negative elements, suppose there are 7 negative elements, I can definitely make pairs of two negative elements and make 6 elements positive. Like here there were 3 negative elements, but we converted 2 into positive and only one negative was left, right? So whenever there are odd number of negative elements, only one would be negative at the end and we can decide which one. Because suppose it is 1, 2, -3, 4, I don't want -3 to be negative, I want 1 to be negative. So I'll perform operation on this two, it would become -2, 3. I'll perform operation on this two, it would become -1 and 2. So minus sign is transferred to this element. So we will transfer the minus sign to the element whose contribution is the least. So do you have any doubt till here? Otherwise we'll start with the implementation part. And there are 61 people in the stream. I request everyone, please like this video if you are understanding my explanation and if you like it. Thank you. Thank you for liking. Make sure to like the stream. So got it. Okay, okay, yes, okay, Shyam, Jaswant, okay. So we'll start with the implementation then. So first of all, let us, calculate the contribution of each element, right? Or better, no, we are not calculating it, we'll directly add to the answer. Okay, so answer is 0. Then I'll take minimum absolute value, in which I'll store the element whose magnitude of contribution is minimum. Okay, so what I'll do is, in answer I'll assume all the element to be positive, and I'll add the contribution of all the elements. And at the end, if we come to know that there are odd number of negative elements, we'll subtract the minimum absolute value multiplied by 2. Okay, so we will look at that further. Then I'll take one variable x and let's say I. Okay, so let's start. For I equals to 0, I is less than n, I plus plus. So x would be I plus 1 star n minus I. Okay, and x is equals to x star a of I. So this would be the contribution. Now I also want the count of 0 and count of negative elements. So C would be counting my number of negative elements, and 0 would be counting the number of zeros in the array. Okay, so now if x is less than 0, C plus plus. If a of I equals to 0, 0 plus plus, right? What would we add in answer? Answer equal to answer plus absolute value of x, because at present we are adding absolute value. Now we need to compare this with the minimum absolute, because in case there are odd number of negative elements, I want whose contribution was the least magnitude wise. So what I can do is, if minimum absolute is equals to -1, so it is not initialized yet, then minimum absolute is equals to absolute of x, else minimum absolute is equals to minimum of minimum absolute and absolute value of x. So this would work. Then after coming out of the for loop, what I'll do is, if count modulo 2 is equals to 0, so the number of negative elements are even, or there is at least one 0 in the given array, then I'll return the answer. Else what I'll return answer minus 2 times minimum absolute. Now why I have taken 2 times minimum absolute? Because I have considered this minimum absolute in the answer as a positive number, but since I'm making it negative, so first of all its contribution would be removed. So how will I remove its contribution? By subtracting minimum absolute value, right, once, because I have considered every number's contribution in line number 29. So I'll remove it. Now it would be contributing as a negative element, so I need to again add that negative value. So basically that's why it's minus 2 times the absolute value. Okay, I hope you got that. So we will return that. Now let's compile and run. So we have got answer for this. Let's submit it. So we have solved this problem successfully. What would be the time complexity? Time complexity would be big O of n, as we are using one for loop. Okay, so any doubt, please let me know. Okay, someone is asking. Okay, someone is asking to code in Java. Okay, I'll do it from the next live stream. It would be difficult to code in both the languages. So what I'll do is, I'll prepare one code in advance and keep it, and one code I'll in one language I'll code it live. Okay. So Sunil is asking, can you explain minimum absolute part? Okay. So I'll take one example so things would be clear. So suppose my array is, let's say, 1, -2 and 3. Now since there is one negative element, there would be at least one negative element. So initially what I have assumed is, let's say all the elements are positive. So what would be my answer? Answer would be 1 into contribution of number of subarrays in which 1 occurs, plus 2 into number of subarrays in which 2 occurs. and 3 into number of subarrays in which 3 occurs. Now 1 occurs in how many subarrays? I plus 1. So I is 0. So that is 1 into n minus I. N is 3. 3 minus 0 is 3. So it occurs in 3 subarrays. Similarly, 2 will occur in 4 subarrays. Simply 2, 1 and 2, 2 and 3, and 1, 2, 3. And 3 will occur in 3 subarrays. So total would be how much? 3 plus 9 plus 8, that would be 20. But since there is one negative element, my C value would be 1 and there are no zeros. So I know that at least exactly one element would remain negative at the end in my optimal solution. So now this number's contribution is how much? 3. This contribution is how much? 8. And this contribution is how much? 9. So 3 is the minimum. So making this negative is the most beneficial for me. That is what I am doing here. Minimum absolute is equals to minimum of minimum absolute and absolute of x. What is x? X is nothing but I plus 1 into n minus I into a of I. That is the total contribution of that number. So I need to make this element as negative. So when I'll make this as negative, it would be minus 3 plus 4 plus 8 plus 9, which would be 17 minus 3, which would be 14. Sorry, which would be 14. So how will I get 14? See, first of all, I need to remove this, okay? Because this is not positive. So I do minus 3. So this is the remaining part. It is how much? 17. And this will give me 17. But this is contributing, but in a negative way. So I need to add minus 1 into 3. So still I have to do one more minus 1 in the total sum. So this becomes 14. So that's why I am doing answer minus 2 times minimum absolute value. Did you got that point? Okay, 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 okay. Okay, so someone is asking to dry run the code. So basically, if I like, I already did a dry run kind of thing on this only 1 minus 2 and 3. So if it is 1 minus 2 and 3, our answer variable would contain how much? 20, as we calculated in the previous equation. My 0 variable would be how much? 0. My count variable would be how much? 1. So what will happen in the if condition? I will be executing line 41 in the of the else part, and the minimum absolute value would be 3, because I have one as 3, one as 8, and one as 9. So I'll subtract minus 2 times 3 from 20, so I'll get 14. Okay, nicely explained, thank you. Someone is asking, go through the code once again and explain it once again. Okay, let me explain it quickly. So basically, see, we need to, we are given one operation which we can perform any number of times on the given array, and we need to maximize the sum of all subarrays of this given array. Now in order to maximize the all the sums of the given subarray, I want maximum number of elements to be positive. So if you look at the concept clearly, if all the numbers are positive, we do not need to make any number any operation. If there is at least one zero, so what we will do is we will be able to make all the numbers positive, because like suppose there is 1 minus 2 3 and 0. So what I can do is I can perform operation on this, so 2 will come here and minus 3 will come here. Now I can perform operation on this, so this will become plus 3 and this will become minus 0, which is basically 0. So whenever there is a 0, we can dump all the negative signs into 0, because like we can transfer the negative sign one step and 0 will remain 0 only. So if there is at least one 0, I can make all the elements positive. If there are even number of negative elements, even then I can make all the array elements positive. So for example, here we have minus 2, minus 4, minus 7, and minus 8. So I can perform one operation on this, so they both will become positive. I'll perform one operation on this, so minus sign will come to 3. Then I'll perform one operation on minus 3 and minus 4, they both will also become positive. So all the elements become positive. There is only one case remaining, that if the number of negative elements are odd, in that case there would be at least one negative element remaining at the end. So what we do is we calculate the sum of all the subarrays, calculate considering all the elements to be positive, and if there are odd number of negative elements and no zeros are present, then we consider the element whose contribution is the least as negative element. And what is the contribution of one element? It is n minus I into I plus 1 into a of I for the ith index element. So now we'll quickly go through the code. So what I've done is I have looped over the element. Here x gives me the contribution. So x is I plus 1 into n minus I into a of I. If x is negative, I'll increment the count variable, which represents the number of negative elements. If a of I is 0, I'll increment the 0 variable, which represents number of 0 elements. Considering this to be positive, I'll add it to the answer. And in minimum absolute variable, I'll store the value whose contribution is the minimum. So if it is equal to -1, then I'll directly store this because I have initialized it to -1. If it is not -1, I'll compare it with the current value. Finally, if my number of negative elements is even or there is a 0, I'll return the answer directly because I can make all the elements positive. Else, I'll return answer minus 2 times the minimum absolute value. I hope you have got it now. Now, so Puneet is saying Karan is the boss. Thank you, Puneet. Okay, so thinking about the logic won't be possible if this problem was never encountered before. I would say it would be difficult to think about this logic in given the time constraints. Like if there are no time constraints, then you will ultimately get it if you like think for a very long time. But yes, it was quite difficult to think about this when there are time constraints. But what you could have thought of is, see, we want sum of all elements of the sub array, right? Now the value of n, that is the size of the array, goes up till 10 to power 5. So you cannot go of n square algorithm. You cannot also do n log n because here there is nothing like binary search or something, right? So even sorting wouldn't help because we want the element position to be at that position only. So then you could think of that, okay, what would be the contribution of each element, because now I need to do it in linear time. So that is the first hint. Second hint is, whenever you select a length 2 subarray and multiply it with by -1, if both the elements are negative, both will become positive. If there is one negative element, it will transfer the negative sign to the other. So now from here, the one thing which should come in mind is, if there is a 0, we will dump all the negative signs into it. If there are even number of negative elements, we'll keep pushing the negative signs until pairs are formed and make all of them positive. And for the odd number of negatives, one would remain, and we will subtract the minimum contribution element. Lovely explanation. Thank you, Rohan. So any doubt? Otherwise, we'll move on to the last question. Okay. Okay. Okay, so we'll move on to the last question. So the last question is geek and buildings. You are given an array heights of n elements whose ith element denotes the height of the ith building. Okay. Geek likes to jump from one building to another. He only jumps to the next taller building and stops when he reaches the tallest building. Okay. The energy required for this journey is XOR of all the heights of the buildings on which Geek jumps until he stops. Geek can start his journey from any building, find the maximum energy required before he starts. Okay. So basically, what the question is saying is, you are given an array of elements which basically represents the height of the buildings. Okay. So that is A1, A2, A3, A4, A5, A6, A7, A8, right? Now you can start jumping from any of the buildings. So any of the building can be your start state. Then how will you jump? You will jump to the next building which is taller than the current building. Okay. So suppose I am at A3. The next taller building is A5. So I'll go here. Suppose the next taller building is A6. So I'll go here. Suppose the next taller building is A8. So I'll go here. Now there is no building on the right hand side. Suppose here it was A9, but A9 is shorter than A8. So I'll not go further. So I'll stop. Right. So the energy required in jumping from A3 to A8 would be the XOR of the height. So A3 XOR A5 XOR A6 XOR A8. Okay. So out of all the possible combinations, I want to find the maximum energy path, and I want to find the maximum energy required on any path. So basically I need to return the maximum energy which would be required in any of the case. Okay, this is the question. Now understand one thing. If we look at this example, suppose I am starting with A3. I went till I suppose. So let's divide this question into two parts. First part, suppose I start from A3. Okay, now I looped. I using loop, I'll keep going on the front. Whenever I find an element which is greater than the current element, I'll take it. Okay. So suppose I start with A3. Now, so my answer would be A3. Then I go to A4, but A4 is not taller than A3. Then I go to A5. A5 is greater than A3, so my answer would be A3 XOR A5. Okay, now I want a building taller than A5. A6, A6 is taller, so I say answer equals to, or let me put this sign only, A3 XOR A5 XOR A6. Okay, now A7 is not taller than A6. A8 is taller, so this would become XOR A8. Now A9 is not taller, so this is my this is my answer when I start with A3. Now if I start with A1, A2, A3 and consider all the different cases, I'll get n different answers, and for all n different answers I'll store the maximum in one variable. Okay, and I'll return it. Now, first thing to observe here is that a sub problem is used to solve like there are overlapping sub problems. How? If I start from A3, my journey would be A3, A5, A6, and A8, right? If I start from A5, my journey would be A5, A6, and A8, because from A5 I'll go to A6, and from A6 I'll go to A8. If I start from A6, my journey would be A6, A8, and if I start from A8, my journey would be only A8. So in this case, my answer would be this much part. In this case, A6 and A8, my answer would be this part. And in the last case, my answer would be only this much. So the smaller answers, like there are overlapping sub problems, I can say. So what I can do is I can start traversing from the back, and I can store the answer of each. So I can say dp of index 8 will store A9, then dp of index 7 will store the answer starting from A8, and so on. So what will happen is if I start traverse from the end, so I will have dp of 5 stored. Let's say I have traversed till index 5. Now when I'll come to index 3, and as soon as I loop and I find moving from A3 that A5 is the next higher element, I do not need to calculate the whole thing. I can say dp of index 2, that is A3, is equals to A3 XOR dp of 5, because dp of 5 is nothing but A5 XOR A6 XOR A8, so I do not need to traverse again and calculate the whole thing. So this is first thing. We will use dynamic programming because there are overlapping sub problems. We will start from the end, because uh, those would be the sub parts which will overlap with the elements starting from before that. Okay, so this much is clear. Now the second part is, if starting from each index to find the next greater element we loop over the array, then that would take in worst case big O of n square time, right? Even to find the next greater element we would need to loop. So rather than, what we can do is we can find next greater element using stack. That is the standard approach. Using stack, we can find next greater element of all the arrays in big O of n time. So first we will find it and store it. So I have an array next which represents the next index of the next greater element where I will jump. I will have one array dp which will store the, so dp of I will store the energy required when I start with index I. So what would be my formula? My formula would be dp of I is equals to heights of I, that is the height of the current building, XOR with dp of next of I, because next of I will represent the next greater element and dp of that element would be the energy required from there onwards. So overall energy required from ith index would be this much. So now I need to fill this and this table. So first of all we'll fill this, and then using the for loop from the back we'll fill dp table. So is the concept clear? Now we'll move on to the implementation. Let me know if there is any doubt. Okay, so any doubt? Okay, someone is asking stack is not clear. So basically, we use a stack. This is a standard question on stack. We use a stack to find the next greater element for all the elements of the array. So what happens is, basically, suppose I have elements 5, 2, 3, let's say I have 4 and I have 2, okay? And let's say I have 6. So let's remove 2. So I have 5, 3, 4, 2, 6. So what happens is, initially we take empty stack. Now for 6 we will mark -1 because there can be no greater element than 6, right? So then, and we will push 6 into the stack. Now we will traverse in this direction, okay, because next greater element will be on the right hand side. Now we check the top element of the stack. Is it greater than 2? Yes. So that is the next greater element and we push 2 into the stack. Now for 4, is this the next greater element? 2? No. So we will pop it out. Is 6 the next greater element? Yes. So 6 would be answer for this and I'll push 4 into the stack. For 3, is 4 greater than 3? Yes. So this would be the answer and I'll push 3 into the stack. For 5, is 3 the next greater element? No. So I'll pop it out. So my stack would be 4 and 6. Is 4 greater than 5? No. So I'll pop 4 out. Is 6 greater than 5? Yes. So 6 would be the answer for this and I'll push 5 into this. So I got the next greater elements for the complete array. Now instead of values, I can also push in the stack indexes. I can push in indexes of the elements if I require indexes of the next greater element. And how much time this operation takes? This operation will take big O of n time, because we are traversing this array once, and all the elements in the stack will be pushed in once and popped out once maximum. So stack would take 2n number of operations maximum, and traversing the array would take n operations. So basically it's big O of 3n, which is nothing but basically big O of n. Okay. No, geek cannot jump from back to front. It can only jump in the front direction. Varun, is this clear? Using the stack, why we use stack? Okay. So I'll start implementing. If you still have any doubt, just put in the comments. I'll answer it after that. So I need a stack to find the next greater element. I need an array of size n which stores the next greater element. Then what else do we need? We need to find the answer, so I'll take answer as 0, right? I need an dp array of size n, and let me take one variable I and one variable x. Now next of n minus 1 would be minus 1, because there is no greater element on the after the last element, and I'll push into the stack the last element, so it would be n minus 1. Now while or for I equals to n minus 2, I is greater than equal to 0, I minus minus. Initially assume that this index do not have next greater element. So next of I equals to minus 1. In case we do not get any greater element for this, so minus 1 would remain at index I. Okay. Now while stack is not empty, if the top element of the stack, so in stack we will be pushing indexes, because we need indexes and not the value of the element while filling up the dp array. Okay, so if uh, heights of s dot top, because in stack I have index, so I need to access the value from the heights array, is greater than heights of ith index, then next of I is equals to s dot top, right? And we will break from here. We do not need to go further, as else we will pop out that element, and after coming out of the while loop we'll push the current element, so s dot push index I. So now I have the next greater element indexes stored in next array, right? Now dp of n minus 1 would be heights of I, heights of n minus 1, because there is no other element, so it would be like this. Or we can do it, we can take it inside the loop as well. So for I is equals to n minus 1, I is greater than equal to 0, I minus minus. If next of I equals to minus 1, means there is no next greater height building on the right hand side. So we will, if we start from that building, we will consider only that building. So the energy required would be dp of I equals to heights of I, only that would be considered. Else dp of I would be heights of I XOR dp of next of I. dp of next of I will denote how much energy you require starting from the next greater element. Okay, and we will XOR it with heights, and answer would be max of answer comma dp of I. We will put this every time. Okay, and at the end we will return the answer. And now let's compile it. So we have got the correct answer in sample test case. Let's submit it. So we have solved this problem successfully. If you have any doubt in the implementation or concept part, please let me know. And if you have understood everything, then before leaving, please make sure you like this live stream. If you have understood everything and if it was good, there are 50 people in the stream. Make sure you like the stream. Thank you. Thank you for liking. Thank you. Okay, Varun. Okay, line 22, y minus 1. Okay, so basically see, so the question is, why are we initializing next of I as minus 1 in before finding the answer in the stack, right? So minus 1 denotes that there is no greater element on the right hand side of it, right? So suppose my array is, let's say, 3 and 4, sorry, 5, 2 and 3. So initially for 3 it would be minus 1. I'll push 3 into the stack. Now 3 is greater than 2. So here 3 would be stored, or I am storing the value, not the index. So value 3 would be stored. Okay. So then I'll push 2 in the stack. Now 2 is greater than 5. No. So pop it out. 3 is greater than 5. No. So pop it out. Now since the stack is empty, we'll come out of the while loop, but we need to fill some value here, otherwise it will be garbage. So what I have done is, before looping over the stack, let us initialize it at minus 1. So in the worst case, if there are no next greater element, it will remain minus 1, which denotes that there is no greater height building on the right hand side. and in case there is sum, this minus 1 would be replaced. So what will happen is for 5, 2 and 3, this would be minus 1, this would be initialized as minus 1, but since 3 is greater than 2, it will be replaced by 3. So here I am writing the value 3. Okay, don't mix it up with our code. In our code we were writing the index value. Here I am writing the value. Basically what I'm trying to say is that minus sign will be overwritten in case there is some next greater element. Okay, so did you understand this? Someone is saying he became expert on code forces thanks to my videos. It helped a lot. Okay, Ketan, you are welcome. Glad to hear that. Why loop starts from I minus 2 and not I minus 1? It starts from n minus 2, not I minus 2. Because the last element cannot have next greater element. So we have initialized next of n minus 1 as minus 1 and pushed it into the stack and start the loop from n minus 2. Is this much clear? Okay. So any doubt remaining, please let me know. Can we remove an array by using two variables like current and max? I didn't got the point. Can you brief a little bit more? Someone missed today's constant due to assessment. No problem. You can try it offline. Give it a shot according to the timelines, and then solutions are available in this live stream. You can watch it on YouTube. So Nayan, can you like explain a bit more? What are you trying to say? So I hope you people have understood all the three questions and got the concept, logic, and as well as the implementation part. Okay, you got it. Okay. Okay, no problem. You are welcome, Nayan. So any doubt, please let me know. Otherwise, we'll end the stream. Okay, so someone is asking me to explain the DP part. Okay. So basically, see here. Suppose my array is A1, A2, A3, A4, A5, A6, A7, and A8, right? Now, suppose I start with A3. Then, suppose A5 is the next greater element. So, I'll go to A5. From A5, the next greater element is A6. Suppose, so I'll go to A6. Suppose the next greater element is A8. So, I'll go to A8. So, what would be the energy required? It would be A3 XOR A5 XOR A6 XOR A8, right? Now, what if I start from 5? I'll go to A6 and then A8. So if I start from 5, the energy required would be A5 XOR A6 XOR A8. If I start from 6, it would be A6 XOR A8. And if I start from 8, it would be A8. So this is overlapping sub problems. This A8 sub problem is repeated in all of them. A6 XOR A8 is repeated in the first three. A5 XOR A6 A8 is repeated in the first two. So why to calculate them again and again and waste time? So where what we do is we start from the end. So first of all, A8 would be calculated in DP of 7, that is seventh index. Then when I'll come to 6, I know that seventh. When I'll come to A6, I know that next index is at 8. So DP of 5 would be nothing but A6 XOR DP of 7. Similarly, I will count DP of 4, that is for A5. Then for A3, that is at index 2, I can say dp of 2 is equals to dp of 4, because 4 is the next greater index, XOR A3. I can directly say this. I do not need to calculate A5, A6, A8 again. So we are solving the using the solution to the sub problems to solve the other problems. There are overlapping sub problems. So this is dynamic programming. So that's why we are moving from end to start and storing the values. Is this clear? Your code forces post contest is superb. Thanks. You are welcome, Om Prakash, and thank you for your kind words. It means a lot. Okay, it's clear. Okay, any other doubt? Please let me know. And before leaving, please like the stream if you liked it. I can say you are the best I've seen in post contest discussion. Thank you, Pawan, for the kind words. So, any other doubts? Please let me know. Otherwise, we'll end the stream. If no doubts come, let's wait for a 1 minute or so, and then I'll end the stream. Okay, so he has missed second question due to network issue. I have already explained the second question 2 times, and you will get it absolutely clear. So you can watch it once in this recording, and in case if still doubt remains, write in the comment. I'll definitely answer it. Okay. You want to see the dry run part? Okay. So I showed the dry run also on one. So basically this was the dry run. So I have also done a dry run. Okay, so I have defined the whole solution starting from the basics, the concept part, then the implementation part. Then someone asked me to do a dry run, so I have also did a dry run on one example. So it is already covered, right? And you will get it. Even after that, if you do not get it, then just write down your doubt in the comments in this video only, and I'll reply it. Okay. Okay. So we'll end the stream here. Thank you guys. Thank you for joining. And good night. Take care.